Assalamu alaikum warahmatullah shabab. Welcome to Innovarix, the data science for Algeria or Algeria in data science free 15-week program. We are now in week number 7, and this could be our last and final round in regards to data preparation and processing. So yesterday we talked about the how to deal with missing values. We talked about how to deal with outliers, and also we talked about how to deal with the skewness. These are some of the enemies that you need to fight as data scientists to make your data ready for analysis. The reason why we need to prepare our data is one of the maybe the most reason why we need to prepare our data is to reduce the bias as much as we can. The bias always going to be there, but we need to reduce it as much as we can. Of course, there are many techniques or many pre-processes that you need to apply. It totally depends on the data that you have, and also depends on the problem that you have. But these are some of the some of the common methods, most common methods that we required to make your data ready. Okay, so and we did most of this. So far. So one things, if you are doing classification or regression, you might need to check how good your target variable is. If you are doing classification, you might need to check the balancing of your target variable. If you are doing regression, you might need to check the normality distribution of your target variable. Normality of your target variable. If you are doing these two, and you might need to check, as I said, the target variable. Of course, you need to remove any noisy data, redundant data, or duplicate data. You need to deal with missing values. I'm not saying delete missing values, as I'm saying dealing with missing values. Of course, yesterday we learned about more than 5 options. It depends. So you could delete column wise or row wise. You could replace, or you could impute with mean, median, and mode. You could predict using the machine learning. You could use any robust machine learning that don't really care about this type of deficiencies in the data. And we also talked about the outliers. The outliers, they are your second enemy, your third enemy that you need to fight, and for a reason or another, somehow you need to deal with these outliers. So an outlier is any element of your data that lives extremely too far from the majority of your data. It could be one element, it could be a group of elements. So again, when dealing with outliers, if the outliers are the problem, or if the concentration of your study and the concentration of your analysis is these outliers, then we need to keep them. They are going to be they are called now anomalies, and we need to detect them and learn them, study them, and of course eliminate them. If the majority is the focus, or is the main reason, or the main elements of your study, then we need to deal with these outliers. And of course, dealing with outliers depends on the significance of these outliers, the power of these outliers, the quantity of these outliers. So you could delete them, you could scale the entire data set, and to reduce these outliers, you could split your data into outliers and inliers, or normal data. You could use also some robust machine learning that don't care about this type of deficiencies in your data. Cardinality, we talked about it a few weeks ago, is when you have a column that is categorical data with many levels of many levels or many subcategories or many classes. So if you planning to use this column, you are gonna be most likely you'll be required to transform it into numerical data. But because it has so many cardinals, so many levels, so many classes, so you might need to reduce the cardinality first. How we can do that? We could simply create some categories out of it. Like for example, if you have a list of jobs, so we got 300 jobs in there, we could categorize these jobs as either technical or non-technical. So instead of having one column with 300 jobs, we are going to have one column with two jobs with two categories only. Data conversion, here we are talking about categorical data. You need to transform your categorical data into numerical data. Why is that? Is because most of the models that have been designed so far, they deal better. They are designed around numbers, and they deal better with numbers. So we need to transform our categorical data into numerical data. But before we transform the categorical data, you need to know the type of categorical data. Is it nominal? Is it ordinal? Or is it binary? Because the type of target variable will determine the type of transformation. Of course, yesterday we talked about the numerical data transformation is the skewness. So we are going to calculate the skewness. The right skewness or the better skewness is that skewness that equal to 0. So skewness equal to 0. If you got a skewness greater than 0, that is a positive skewed or skewed to the right. If you got a skewness of a variable of a column less than 0, that means that you got a problem in the left tail of your data that is skewed to the left. And depends on the type of the skewness, we could use a different transformation method. If it's positive, then we are going to use logarithm to transform it. You could use the inverse method. I think it's called the inverse method. Or you could use also the square root method. If the skewness is negative, then we need to raise the value of this value of the figures of the column by powering it to a number. So we could power it to the 2 and 3 and 4 and 5, etc. So then other techniques, we could do normalization, which is simply scaling and putting all your data between 0 and 1. Why is that again? You'll be using machine learning, and machine learning requires they are very sensitive. Machine learning is simply a mathematical algorithms which is very sensitive towards dominating numbers. If you got numbers that they are higher, of course they will be dominating. the learning. So we want to make sure that all our data is scaled to avoid having to deal with an algorithm that favors large numbers over small numbers. Factorization is transforming your categorical data into factors into category. Sometimes when you read your categorical data, it might not be read in the right format. So binarization, like if we have a column yes and no, then we are going to transform it into -1 and 1 or 0 and 1. Standardization is similar to the normalization. It's simply using different mathematical equation to scale your data. Correlation, we talked about it several times. When we are talking about correlation, we are talking about the x versus y and x versus x. So x versus the correlation between x and y, we are going to keep all features that they are very closer, they are not equal or closer to 0. Okay, x and x, we are gonna keep all features that they are equal or closer to 0. And data aggregation binning is there are some type of dimensionality reduction. Decomposition is used for time series. In time series analysis, has 4 components. It has trending, seasonality, cyclical, and irregularity. So we need to remove trending and seasonality from your data and cyclical and deal with the remaining. The most important step in preparing your data is feature engineering and feature selection. So, feature engineering is creating new features out of the existing features. So creating new features out of the existing features. The feature selection is selecting features from the existing features. We are not creating anything new. It's simply selecting features based on the power of prediction, power of influence, and of course we are going to eliminate features that don't have any impact, any power, any prediction power. Feature engineering, sometimes you are going to get you have a data, but your data does not take you anywhere. So what you could do as data scientist is look around your data from 360 view and see if you can come up with a few features or new features that you could use for your prediction. And finally, you are going to have a better version. So this is the version we are going to use. We are going to be ready for next week for machine learning. So any questions, concerns about this so far? Okay, got some questions. I have a question about classification to reduce the high cardinality. Like we said, for jobs, we can divide it into technical, non-technical. Could we do something else like IT jobs? Yes, you could do that. Yeah, you could do that. If you have a column, let's say you have one column that is, sorry guys. So this is not. So you got a column. Let's say that we got a column that is called jobs, and you've got 300. You got 300 jobs. You got 300 jobs. So what you could do instead of having 300 jobs, you could categorize it into IT, non-IT. You could categorize it into like IT jobs, medical jobs, farming jobs, education jobs, etc. But try to make it less any method that would reduce the cardinality of your data. That will be great. Doesn't really matter, but yeah, that is one way of reducing the dimensionality. And after that, you could transform your categorical data into numerical data. Okay, Adil, are you clear?
Yes, sure.
You're welcome.
Thank you.
You're welcome. Okay. So yes, that is most of most of this data preparation. Of course, we're trying to reduce the amount of. Unfortunately, this is a free program. We are not going to cover everything, but we have covered so far the most important part, the most important steps needed for preparing your data. So we started with file number 1, where we read the data. Now the claims data, we got 1,000 features. We got 1,000 1,000 claim, 1,000 accident, and it comes with 39 features. And we reduce the dimensionality by eliminating features that we know don't have any value, using our common sense, using our knowledge base. So we removed any constant values. We removed all the IDs, features. We removed the features with too much personal information, like names of the client, email addresses, phone numbers. Then we reduced the dates, because we are not going to use time series analysis. And of course, we removed the high hierarchical data. So if you got a city, you got the state data, city data, county data, and you also have zip codes. So we are going to keep only one of them, because they would give us the same information except with less or more details. So that is what we did in file number 1. Of course, we learned about the insights. We used we concentrated a little bit on data visualization, and we were able to determine some insight that would help the business make some decisions right on the fly. So this is what we have gained, or what we learned from file number 1. So if you guys remember this bar plus comparing the policy state and incident state, we find out that maybe 97% of the claims that have been reported, they were being reported out of the states that issued the insurance. That simply means that 97 of our clients, they are traveling, so you might need to raise the premium for any client that drives more than 50 miles per day, I would say. So file number 1, yeah, that was file number 1. So we got file number 1. We got a data with 1,000 features by 1,000 records by 39. So we reduced this this is what we did in file number 1. We reduced the dimensionality using correlation analysis, and also using knowledge base. Knowledge base, we removed anything that is constant, anything that is too personal information, etc. Correlation analysis is with this method. That is file number 1. File number 2, alright, this is version 1. version 2, we got this same data, and what we did, we replaced question mark. If you remember, guys, you got some question marks in there. You got some question marks. So this could be a missing value. It could be anything. So we replaced this question mark using the imputation with mode, and also we transformed the categorical data. The categorical data into numeric, and of course we increased the number of features maybe to 133. So this is version number 2, and you could do this in one file, in one version, but because we are learning, we're trying to see everything clearly. So then we moved into file number 3, the same data, and now we dealt with missing values, then outliers, values, and the skewness. Okay, and now we got version number 3, and finally with this version number 3, we need to reduce the dimensionality one more time. So we need to reduce the dimensionality, and we are going to have version number 4, which is could be our final version, or the version that we need to use for the machine learning starting from next week. Okay. So yeah, the file number 2 got a data, and we deleted some features. We transformed the question mark into we imputed the question mark, or replaced the question mark with an unknown. Then of course we checked the transformed the categorical data to numerical data using the dummy variable. Of course, we learned other techniques, but we used only one technique, that is dummy variable. So we had 39 features, then we went down to 29, then after transformation, now we have maybe 133. Okay, 133 features. Then back in file number 3, which is 4, we read the version number 3. We got 133 features, and we had to deal with missing values, outliers. Luckily, there is no missing values in our data, and we got few outliers, but we were able to live with them. And yesterday we learned about how to determine missing values. It could be determined by one method, and that is in A, is null, is empty. And please be mindful that this is in A only looks for the empty cells. And yesterday we talked about missing values, and we talked about that missing values could be more than an empty cell. So it could be a 0 in there, it could be a special character in there, it could be a value that don't belong to the same category. And I gave you an example of the old schools. My parents, from where I came from, the Atlas Mountains, at the time, back in the late 20s, 30s, and 40s, when the Moroccan government start building the database of the civilians. So they start the process of providing IDs, and at that time there is no nickname, there is no last names, it's all one name, Fulan, Bni Fulan, Bni Fulan, and if there is no نيك مكاينيش هاد الكنيات جات مع الاستعمار الفرنسي البغيض بين قوسين. So my family, my mom and my dad, they didn't have any date. They simply come up with a date. She was born or he was born, when something happened, or they simply they figure it out. They guess, and since they cannot guess the month and the day, they put for everybody January 1st for everybody. So January 1st is a missing value. It is we have a value in there. We have 01 and 01 and the year, but we don't have but the 01 and 01 January 1st is not an actual value, it's simply a guessing value that would be considered as a missing value. But if you were to do is NA, you are going to get zero back, because the cell is not empty. So be careful when you are looking for missing values. Don't look for only for empty cells. So when you are looking for for missing values, please be mindful that if you were to use this SNA, is only going to look for a cell that is empty. So we could use the missing no library, and this is one library that visualizes your missing values. You could use bar plot, heat maps, scatter plot, I think line plot, and so then we learned how to deal with these missing values. If any, we could drop them. We could delete the column, we could delete the row with an NA, mark the value as none. You could impute using mean, median, and mode, and we learned about when to use mean and median and mode. Mean if there is no outliers in the column. Median if there is no outliers. Mode if your column is categorical. Of course, there are other techniques. You could split your data based on the column into data, complete data and missing data. So we could, let's say for example, you have a column that is called age, and it has 20% of age are missing. So what we could do, we could split the data into 80%, 20%. So for 80%, we are going to use age as a target variable. So we are going to learn a pattern that we are going to use to predict the age as a target variable for the 20%. We could do that. So there are many techniques that you could use to deal with missing values. Depends on the quantity and the quality of these missing values. Then for the outliers, again, there are many methods. We could use data visualization box plot. Box plot tells you where in the data, in the column, you have a problem. It could show you the outliers that they are going to be obvious and clear. They will be shown either the top beyond the upper boundary or upper fancy and lower boundary. You could use the IQR score. We could use QQ plot. This is another best method to determine if how closer your features or your columns to normality. If it's not normal, means there might be either an outlier in there that that disturbing the statistical analysis of your column, or it might be a strange variable, it may be a missing value, an outlier, etc. Then we learned about the Z-score as another technique to determine if you have an outliers or there is no outliers. So now we got a data almost done, and so let's take a look into final final version. So this is the final version, and we need, as you might see, it's 1,000 features and 133. 1,000 features and 133. 133 is unfortunately too many features for 1,000 columns. Please remember, in a real life scenario, the best data that you could learn from, a better statistical model, is a data with less features and more rows. So you got millions, it's good. You got less than 50, that's good. So this is the best data that you could use to learn. If you have a data with, let's say, with more features, with many features and less more rows or less rows, then you might end up having a problem with cursive dimensionality. I'm going to show you school summaries. Let me share with you ways to handle or deal with this reducing dimensionality. Okay, ensemble. Yeah, I'm looking for the slides, so please bear with me. This is the ensemble method. This is not it. Yeah, this is what I'm looking for, but it's not well detailed. Okay, so when we are talking about reducing the dimensionality of your data, of course, why do we need to reduce the dimensionality? There are many reasons, so let's talk about a few of them. We are going to talk about 1, 2, 3, and 4. And this is a question for you all. Why do you think we should reduce the data dimensionality? Why? Please take the mic and do your best. You don't have to answer correct, but we are here to learn from one another. Why do you think we need to reduce the data dimensionality?
To reduce the variable.
There is a question, why do we need to reduce these variables? Why? علاش؟ شنو هو المشكل اللي غادي نوقعوا فيه الا خلينا بزاف ديال لي فيربلز؟ everybody كلكم please شاركوا.
ما نقدروش نعرفوا المتغيرات كي تكون كثيرة، لازم تكون قليلة باش نقدروا
علاش خصنا نقللوها؟
القراءة تاعها تكون أسهل.
Yes, that is one variable. بطريقة أخرى if you were to visualize them make إلى عندنا variables قلال visualization database is going to be easy. ما تقدرش تقدر مثلا visualization ديال two variables 3 4 ولكن ما تقدرش دير data visualization ل 20 variable ولا 300 variable. تقدر ديرها ولكن ما تقدرش تقراها. what else؟ اشنو هو علاش بغينا نقصوا علاش بغينا نقللوا من ال variables؟ يا لاروسي عبدو عيشة please take the mic. please take
ممكن الحساب.
نعم
ممكن تسهيل الحساب.
yes ماشي تسهيل الحساب reduce
the complexity
time الوقت ديال الحساب.
yes.
نعم إلى عندك مثلا 1000 كلاينت وعندك 39 راه ماشي بحال إلى عندك 1000 وعندك 133 كاين الفرق. time processing reduce time processing make the visualization easy. بعض المرات يعني we reduce the dimensionality because of the limitation of systems. مثلا البي سي ديالك no worries البي سي ديالك مثلا القديم يعني الله كيتقاتل يعني باش تعطي 1000 على 133 is gonna take forever ويقدر كاع ما يخدمش. عندك ذاك الكاباسيتي والميموري ديال السيستمز ديالك يعني ما كتساعدكش. ولكن الا عندك مثلا واحد very powerful computer of course this is not going to be a problem. Number 4 limitation of model algorithms. شي algorithms عندها حتى الميموري ديالها قليل يعني ماشي يعني it's not going to work for high dimension data. لكن الخايبة كاع فيهم كتسمى الكيرس of dimensionality. الكورسين هو ديك بحال قلتي لعنة ديال بزاف ديال الفاريبلز. اشنو هو الكورس اوف dimensionality؟ بلا ما ندخل في الرياضيات المعقدة ديالها دابا إلا عندنا two columns مثلا هما هادو وعندنا 1 2 عندنا 3 الزباين عندنا مثلا الايج عندنا الانكم وحنا بغينا ندير لهم بريزنتيشن في 3D 2D يعني نلقى واحد الزبون هنا واحد الزبون هنا مثلا واحد الزبون هنا اوكي يعني المسافة منين داك الالغوريثمز غادي يتعلم لينا من all the data يعني كل بيانات is going to be one يعني الموديل يتعلم الداتا كاملة. إلا مشينا نزيدو واحد الفاريبل مثلا education level. هي the same data اللي عندنا هي هذه، لكن المساحة ولات شوية كتكبر. يعني المساحة ما بين هاد سميتو 3 is going to be larger enough. المساحة كتكبر. ولزنا مثلا اللي نزيدو مثلا 20 columns، وعندنا نيت لا عندنا غير 3. دابا تكون المساحة ربما حلقة. اشنو كيوقع؟ هذا من كدير الموديل كيشوف يعني كيبقى يتعامل مع هاد داتا بوينت as a cluster. كيشوف غير يعني لأن بعاد بعضياتهم مبقاش كيتعلم منهم مجموعين، كيتعلم من واحد at a time. ويقدر مثلا يتعلم إذا كان هذا عنده الانفلونس يقدر يتعلم غير من هذا و ignore لك الآخرين. هذا هو كتسمى الكيرس of dimensionality، لعنة يعني هذه الكثرة ديال سميتو لعنة الكثرة ديال الفيتشرز. شحال من فيتشرز اللي خصك تكون يعني دو هاف، يعني كيقولوا الى عندك جوج خصنا 10 الى عندك 2 ديال الفيتشرز خصنا على الاقل 10 ديال الريكوردز. الى عندك 3 وقيله كدا 80 ولا كدا 70 ما عرفتش. الى عندك 4 كتطلع ل 500. الى عندك 5 كتطلع خصك على الاقل 1000 وغادي هكاك. يعني ما عرفتش انا يعني، ولكن هذه كنعطيكم الصوره تقريبيه اللي شحال ديال باش ما يكونش عندنا هاد الكورسيف دايمنشناليتي. شحال رياضيا شحال ديال الفيتشرز اللي خصنا نحتاجو الى عندنا عدد ديال الفيتشرز. الى عندنا عدد ديال الى عارفين العدد ديال سميتو ديال الروز ولا ديال كلاينتس ولا ديال انسيدنت، شحال من فيتشرز اللي عندنا. هذه هي الطريقه باش كتحسب، باش ما نوقعوش في يعني في كورسيف دايمنشن. الاخرين سا ديبون على السيستم اللي عندك، سا ديبون على الالغوريثم اللي غتستعمل، سا ديبون على الوقت اللي تحتاج باش يعني باش process your data. بهذا dimensionality reduction يعني تقدر إلا كنتي غادي دير feature selection، تقدر دير feature selection وتقدر دير feature extraction. feature selection يعني غير انت كتختار الفيتشرز ديالك بلا ما دير اي حاجه للديتا ديالك. تقدر تستعمل ماشين ليرنين، تقدر تستعمل نون ماشين ليرنين تكنيكس. نون ماشين ليرنين تكنيكس راه ديجا هضرنا عليهم، النوليدج بيز، دومين نوليدج بيز ولا كورليشن اناليسيس. ماشين ليرنين كاين بزاف ديال لي تكنيكس. فيتشر امبورتانس اللي غادي نستعملو اليوم. تقدر تستعمل الا كدير مثلا فيتشر امبورتانس ديال كلاسيفيكيشن. الا كتستعمل ريجريشن نقدر نستعملو forward selection, backward selection, stepwise selection. كاين بزاف ديال الطرق. هذا الا بغيت تستعمل feature selection. بغيت تستعمل feature extraction دا نقدر نديرو يعني non machine learning techniques. نقدر نديرو aggregation, binning, ratio, flagging and so many other techniques. إلا بغيتي دير machine learning نقدر نديرو principal component analysis PCA, kernelized principal component analysis KPA, LDA linear discriminant analysis quadratic discriminant analysis وكاين بزاف ديال لي تكنيك اللي تقدر تستعمل باش يعني to reduce the dimensionality of your data. Any question please? Any question please? سؤال؟ هل من سؤال شباب؟ Yeah, please raise your hand if anything is not clear. Raise your hand. I will be more than happy to stop and explain it again. اوكي عندنا دابا 1000 وعندنا 133 features، يعني طرق كثيرة اللي نقدر نستعملو using standardized to standardize the data. نقدر نستعملو identify feature with low variance. هادو كاملين templates غير انت حيد لهم هاد triple quotation واستعملهم. نقدر نستعملو feature extraction with PCA, feature extraction with REF, recursive feature elimination. نقدر نستعملو feature extraction with univariate statistical test. يعني كاين طرق بزاف، لكن الطريقة اللي غادي نستعملو ما نقدرش نديرو correlation. unfortunately ما نقدرش نديرو correlation analysis. واي هذه طريقة كنشوفوا بها يعني target variable في علاقة ديالها مع جميع الفيتشرز. يعني this is the target, how the target variable is correlated with all 133 features. يعني كاينة target variable يعني في the minimum, the maximum is 1. The maximum is 1 and the minimum is -1. هذا ال1 هذا هي the target variable and itself. So كاينين شي features they are very close to 0. بحال هذا كاين 0 بزاف ديال 0، ولكن ما نقدروش نستعملو correlation analysis. علاش نقدروا نستعملو ولكن ما غاديش نطيقوا فيه. علاش ما نقدروش نستعملو correlation analysis؟ Anyone please? Why do you think we cannot use correlation analysis? كاينه كيف تختار عيشة شريف، كيف تختار بين هذه الطرق. انت كعالمة بيانات اللي خصك تجربيهم كاملين. يعني ما كاينش شي طريقه باش تقول لي اوكي هذه احسن من هذه. انت خصك تجربيهم وتحاول تيستي. يعني انت كعالمة بيانات you need to find the best method. ومنين كتلقاي شي طريقه اللي كتناسبك، هذا لا يعني بان هذه الطريقه هي هذه اللي لقيتي هي اللي غادي تستعملي غدا ولا في شي بروبلم اخر. يعني منين كيكون بروبلم اخر ديتا اخرى، خصك تعاودي البروسيس باش تلقاي انت الطريقه المناسبه لي. تقدر واحد الطريقه انا كتخدمت ليا باش تخدم لك انت. اوكي عيشه شريف كلير. Okay. Good. Okay, Adil. So we choose between features selection. ماشي كتختار، انت كتحاول تقلص النمبر ديال الفيتشر اللي عندك، سواء استعملتي feature selections feature extraction. المهم في الاخر خصك تنقص من الفيتشرز ديالك. شوف انت الطريقه اللي تناسبك، شوف الطريقة اللي تخدم ليك، شوف you have to test keep testing. السؤال دابا علاش ما نقدروش نستعملو correlation analysis؟ why؟ علاش؟ لأن correlation analysis كما قلت لكم وقرينا وهضرنا على هذه شحال، يعني فاش قرينا correlation analysis. correlation analysis عندها 4 ديال، على ما اعتقد تقدر يكون عندك اكثر، عندها 4 ديال correlation analysis. عندها 4 ديال الشورى. number 1 is numerical data. Number two is going to be pairs of data. Number three is going to be I think it's linear. Number four is real data. real data. استعملنا correlation analysis قبل ما نحولوا categorical data numerical data. دابا عندنا فاش كان عندنا 39 عندنا معلومات كما هي حقيقية ما درناش ليها شي ترانسفورميشن. دابا عندنا 133 يعني وهاد 133 كلها transformed from categorical into numerical data. يعني ماشي اعداد حقيقية ماشي ارقام حقيقية غير ارقام كتبريزنتي لنا الكاتيجوريكال داتا. So we cannot use correlation analysis because our data is not real anymore. البيانات ديالنا ماشي بيانات طبيعية حقيقية كما كانت قبل ما نديرو transformation من 139 ل 133. So تقدر دير correlation ولكن ما تثقش فيه. يقدر يعطيك معلومات خاطئة وإلا عندك معلومات خاطئة أنت غتاخذ قرار خاطئ جدا. So okay good. So يعني ما غاديش نديرو correlation analysis. هو هذا يعني هذا هو correlation analysis ولكن كله معلومات ما غاديش نثق فيها. طريقة يعني ربما الأنسب هو غادي نستعملوا المشين ليرنين. غادي نستعملوا المشين ليرنين باش نلقاو بغينا نبنيو واحد الموديل وبغينا نشوفوا هذا الموديل هذا كيفاش تعلم لنا من البيانات وشنو هما الفيتشرز اللي استعمل باش يتعلم لنا من هذه البيانات هذو كتسمى. كاين مجموعه ديال الخوارزميات الرياضيه عندهم هذه القابليه دي عندهم هذه الخاصيه هذو اللي كتسمى فيتشر امبورتانس. هاد الفيتشر امبورتانس الطريقه اللي غادي نعملوا بها اولا غادي نديروا واحد الكوبي ديال الداتا ديالنا. غادي نشوفوا هذه الكولومز اللي عندنا و to build a model واش غادي نهضروا على هذا الشيء ان شاء الله تعالى الاسبوع المقبل. باش to build a model is very easy. So number one, we need to identify x and y. خصنا نقولوا لهذا الالغوريثم هادو هما الفيتشرز ديالنا وهذه هي target variable ديالنا. We have to identify x and y. You have to identify the predictors and the target that we're trying to predict. That is number one. Number two, we need of course to import the library. يعني خصنا نطلعوا اللايبراري من اللوكال سيستم الميموري. إلا كان decision tree خصنا ندير لها importing. إلا كان random forest إلا كان نطلعوها من scikit-learn من online. So we need to import the library that we are going to use. Number three, we need to split our data into 80% and 20%. هذه من بين الطرق اللي نقدر نستعملوا. كاين بزاف ديال الطرق يعني اللي تستعمل باش تعلم البيانات ديالك وغادي نطرقوا على هذه المسألة هذه ان شاء الله next week. يعني خصنا نتعلموا من 80% ونحاولوا نديروا الايفالويشن داكشي اللي تعلمنا في 20%. هذه الطريقة هذه كتسمى test train test split. ماشي غير طريقة واحدة اللي كاين بزاف ديال الطرق لكن غادي نركزوا على طريقة واحدة. Number 4, we need to initiate the model. غادي نعيطوا على هاد اللايبراري اللي نعيطوا عليها نقول لها اجي كتسمى initiate model، ولا غادي يعني بحال قلتي حركتي الموتور ديال السيارة. we are gonna start model engine. اوكي. نمبر 5 دابا خصنا نتعلموا من هاد نهزو هاد الموديل هذا اللي بنينا، وغادي نقول لي تعلم لينا learn from 80%. سير تعلم لينا من 80%. غادي نستعمل واحد الفانكشن كتسمى الفيت فانكشن، وهاد الفانكشن هادي غادي نعطيوها، غادي نقولها تعلمي لينا من اكس والواي تاو. تعلمي لنا لقاي لينا شنو هي العلاقات الرياضيه المخفيه اللي كتربط ما بين all the features ديال 80% and the target value 80%. يعني من هاد يعني حنا كنتعلموا الموديل، كنتعلموا we learn a statistical model، كنتعلموا واحد statistical model، ولكن ما عارفينش واش هاد statistical model زوين ولا خايب، واش accurate ولا ماشي accurate. ثم number 6 we have to test. we need to test the learned statistical model on 20% ديالنا. غادي نستعمل واحد الفانكشن كتسمى predict، ولكن غادي نعطيوها غير الاكس، غادي نخبيو الواي، نخبيوها ما غاديش نوريوها ليه. و 7 عاد غادي ندير comparing هذاك الاكس الواي اللي خبينا versus الواي اللي الموديل predicted y hat. This is the actual and prediction. Number 8 make a decision. واش نكملو، واش نديرو الامبروفمنت، واش نستعملو شي موديل اخر. على اي حال هادو هما الخطوات سهلين جدا الى شفتو راه من البدايه ديال هاد البروغرام هذا وحنا كنهضروا على البروبلم على الداتا. يعني 80% ديال الوقت ديالك انت كعالم بيانات راه غادي تشتتو غير في business understanding, data understanding and data preparation. 20% هادشي كامل. يعني الموديل راه سهله، يعني الصعيبه في المشين ليرنين كامله في هذاك ديال البروجيكت الاناليتيكال بروجيكت. الصعيبه هي data preparation data يعني الصعيبه هي data preparation و business problem. يعني هاد الثلاثه هادو data business understanding data understanding data preparation راه غادي يديو لك ما بين 70 حتى 85% ديال الوقت ديالك، والباقي يعني 10% 15% 20% الموديلين راه سهله جدا جدا. يعني فهاد حنا دابا ما بغيناش نتعلموا الموديل، بغينا نعرفوا كيفاش الموديل بعدا خدا القرارات ديالو. يعني we are going to make a copy. الان غادي نديروا x and y، غادي نقولوا system this is x and this is the y. so الواي ديال الاكس ديالنا يعني كل جميع all this 1 2 3 باستثناء the target variable. the y is the target variable. يعني الواي هو target variable ديالنا، والاكس everything else. دابا كنهيئوا الموديل كنقول ليه ها الاكس ديالنا ها الواي ديالنا. shape غادي تلقى فيها 132 وهذه كتلقى فيها 1 it's 1. ودابا غادي نستعملوا غادي نمشيو للسايكل ليرن. سايكيلون هي ديك اللايبراري اللي قلت لكم كتستعمل بزاف في المشين ليرنين. سايكي لير هي هادي غادي نمشيو للبروسيسين وغادي نهزو منها بزاف ديال الميثود اللي نقدر نستعملو. يعني this is one of the best library used in machine learning. كتستعمل في classification, regression, clustering, dimensionality reduction. إلا بغيتي تستعمل dimensionality reduction هادي feature extraction, model selection, وكدير يعني كتcompare مع المودلز وكدير pre-processing إلا بغيت ديرها. يعني غادي نمشيو للموديل سيلكشن وغادي نستعملو هذا train test split method وغادي يعني غادي نديرو split على ال x and y وغادي نديرو 20% و 80%. حنا درنا بس سبليت ودابا غادي نستعملو واحد المشين ليرنين, واحد الالغوريثم كتسمى الاكس جي بوست اللي هي فاستر على هي الاكس جي بوست هي اللي the winning model for most of the Kaggle competitions. إلا عندكم مع كاجل يعني مجموعة ديال competitions ديال كاجل, هاد الاكس جي بوست is the winner. غادي نديرو import xgboost كما قلت لكم. غادي نديرو import هي هادي import. غادي نديرو initiate, so we are simply initiating the model. وغادي نديرو لي save في هاد ال variable called model, يعني هذا initiate هي initiate. ثم we are going to learn. دابا غادي نتعلمو من x and y ديال 80%. وفي الاخر غادي نديرو يعني ما غاديش حنا نديرو تيست, بغينا غير نعرفو كيفاش هذا الموديل هذا made استعمل 132 features. يعني كما شفتوا هذا كاع لي features اللي استعملوا شي وحدين رخاويين يعني ما استعملوش. ودابا غادي نديرو نستخرجوا يعني غادي نشوفوا بطريقه احصائيه شكون من هاد الفيتشرز هادو اللي عنده قوه ديال بريدكشن اكثر من الاخر, وغادي نستعملوا التقنيه هذه باش نستعملوا غير الفيتشرز اللي عندهم واحد بريدكشن باور. اوكي غادي نبداو يعني غادي نستعمل مثلا 20 بين 20 largest in largest يعني هادو هما smaller يعني largest in واش largest ما عقدش على
راك ما نحيدش الاس نظن ان largest.
اوكي ثانك يو شكرا اخي شكرا. يعني عرفت يعني انا عقلت عليها نستعمل اكثر ولكن ما انتبهش الاسم. يعني هادو هما الفيتشرز 20. بغينا نديرو مثلا 50 يعني this is the most منين كنوصلوا جوج صفرات كنحبسوا مثلا يعني نحبسوا هنا يعني 20 يعني هادو هما the most powerful features. كما شفتوا الاولاني والثالث راه كلهم على الهابيز. ربما سولتكم هذا السؤال قلت لكم شنو هما الى سولتك شكون هو الفيتشر هنا اللي يقدر يكون the best predictor the most powerful predictor. انا يعني بلا ما نطلع يعني بلا ما ندير الموديلين نقدر نقول لك الايج يعني الناس اللي يعني كبار في العمر كيسوقوا بشويه، كيسوقوا يعني عندهم مسؤوليات. الشباب اللي الله تعلم كيسوق خصو يبان، خصو كسيري، خصو بزاف، وكيوقع في حوايج السهل. نقدر نقول لك أن الage is the best predictor، ولكن it turns out to be الهابيز هي the best predictors. يعني هادوما الفيتشرز، هادوما الفيتشرز الفيتشرز اللي hold on we are going to do largest. هادوما الفيتشرز طريقة ديال استعمال الفيتشرز اللي they are more powerful. هما هادو يعني غادي نمشيو غادي نستعملو حنا في let's modify. we are going to modify. غادي نمشيو هنا غادي نديرو x equal x وغادي نعطيو كاع هاد القيم. okay so what is the shape of x is going to be 30. وغادي نبداو عاوتاني من الاول تقسيم learning. دابا عندنا learning وغادي نشوفو الكوفيشن ديالهم كيما كتشوفوا عاوتاني is the same. كاينين صعب نقدر نكتفيو بغير بهاد 30 وتعطينا تعطينا some good prediction. يعني الفيرجن نمبر 4 فيرجن نمبر 4 ديال اللي غادي نستعملو يعني كامل. يعني دابا نكمل انا نستعملو غير 30 features out of 133. and so now we are ready for the modeling, and next week inshallah we are going to move into building some model, learning some statistical modeling out of this given data. Okay folks, what is important coefficient؟ هذا important coefficient هو يعني كنحاول نقلبو على الفيتشرز اللي عنده واحد القوة ديال prediction. الكوفيشنت ديالو مرتفع، هما اللي غادي نهزو. عندنا 133 ماشي كلهم تستعملوا to learn a model، يعني ماشي كلهم تستعملوا، يعني غادي نستعملوا حنا الفيتشرز اللي عندهم هذا الكوفيشنت ديالهم. الكوفيشنت هو يعني بحال الا قلتي القوه ديال هاد القوه تأثير ديال هاد الفيتشر على تارجت فيريبل. يعني اكبر فيتشر هو total loss، insured chase، hobbies، damage، وغادي هكاك. يعني 0.13%. يعني هذا 10 هذا 10 هذا 0.7 وغادي كتنزل حتى كتلقى صفر. دوك اللي كاينين في الصفر كتحيدهم، دوك اللي كاين اكثر من صفر ولا اقل من صفر كتخليهم. Okay folks, so that's it for tonight.
Thank you.
Yeah, you're welcome. That's it for tonight. I'll see you guys inshallah next Friday. Until then, you guys have a great weekend, and assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. إلى اللقاء إخواتي الكرام.
عليكم السلام.
السلام، شكرا.
مرحبا.